Good morning. Let's continue our example from the last video. So in the last video, I had x squared minus 2x minus 37 over x squared minus 3x minus 40, and we decomposed this fraction into three parts. The first step was we did long division to make sure that the degree of the numerator was lower than the denominator. That resulted in 1 plus x plus 3 over x squared minus 3x minus 40. Notice I had degree 1 over degree 2. And then we decompose this fraction into two separate parts, right? By taking a over degree 1 plus b over degree 1, and we solved for a and b. And if you need to review what that looked like, you can go watch the last video. So this was our a and b, and we can do some keep change flip to write it as three separate terms. Okay, now we said this was a much easier calculus problem when finding the integral than the original problem that we were given. So now I want to talk about something a little more complicated. So what if I had x squared over x cubed? So if I had this expression, I would not need to do long division because the degree of the numerator is 1 less than the denominator. And instead, I could directly factor the denominator. Okay, so remember that is a difference of cubes. And so the difference of cubes would factor as such. Okay, I would have x minus 2, because I take the cubed root of x, put it here, the cubed root of -8, put it here. I would square the first term, multiply the two terms together, take the opposite sign, and square -2. Okay, now here I need something a little different. All right, I have two factors, so I'm going to break them apart. However, the first factor is nice, it's linear, it's x minus 2, so I can put an a on top of that. The second factor, however, is degree 2, so I need to have a degree 1 factor on top, and so I'm going to actually call it bx plus c. So make sure you make a note that when you have a degree 2 factor on the denominator, you really need a bx plus c. And in this case, I'm going to be solving for three missing variables, a, b, and c. But I'm going to do the problem similar to the last one. I'm going to add the fractions by getting a common denominator. So I'm going to multiply a over x minus 2 by a fancy 1. Here's me multiplying by my fancy 1. And I'm going to multiply bx plus c by the same idea, right? I'm going to multiply it by a fancy 1. Notice I did that here. And notice I have parentheses around the binomial. Okay, so I can put these together over one fraction because they have the same denominator. And remember, I can say that that's equal to what I started with. Okay, so now I have a situation where I have two fractions equal to each other. They have the exact same denominator, which means I can set the numerators equal. Okay, so in my next step, I have 10x squared plus 12x plus 20 equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Now, you may be wondering what I'm doing here. In this case, I need to solve for a, b, and c. So, since x can be anything I want, I'm going to let x equal 2. By letting x equal 2, that gets rid of b and c and allows me to solve for a, because 2 minus 2 would be 0 here. So if I plug x equals 2 into the entire equation, okay, so follow my math, plug it in, plug 2 in everywhere. Okay, remember this is all canceled to 0. I'm going to get that 84 equals 12a, or that a equals 7. I'm going to pause just a second to give you a time to catch up here. And now that I know that a is 7, I can use that going forward. And in my next step, I'm going to plug a equals 7 into the equation. But now I need to think of another value for x. Again, something super, super easy to allow me to solve for a different variable. So the next choice would be to let x equal 0. Now why does that work? Letting x equal 0 would allow b to cancel out and allow me to solve for c. So you're going to go ahead and plug x equals 0 into your equation. Okay, keeping a is 7, that's still the case, right? X is 0. And now you're going to solve for c. Okay, this is going to be 28 minus 2c equals 20 on the right, or sorry, on the left. And then I'm going to subtract 28, divide by -2 to get that 4 equals c. So I now have a and c, and I just need b. So now I need to pick a third x value. I can't pick 2. I already chose 2, and I can't pick 0. So I need something super easy because I need to solve for b. And in my opinion, there's nothing easier than x equals 1. 1 is just a super easy number to work with. So I'm finally going to pick x equals 1, and I'm going to plug that in to my equation. Okay, keeping a is 7. Again, I know b, right? Oh no, I'm sorry, I'm looking for b. Okay, and when I do the math, I'm gonna get, so that's gonna give me 42. That's gonna equal, this is gonna be 7 times 7, so 49. This is going to be plus b plus 4. That's going to be -1. So I'm going to put the -1 here. And that's going to give me, let's see, so that's going to be 49 minus b minus 4. And then I will get that b equals 3. So make sure you agree with me. Right, 49 minus 4 would give me 45. I subtract it to get -3, but then -3 equals -b, so b equals 3. And so my mystery is solved. What I now know are the values for a, b, and c. So what that means is up here, my equation is, instead of a over x minus 2, it's going to be 7 over x minus 2 plus b is 3, so 3x, c was 4 plus 4 over x squared plus 2x plus 4. And these were my fractions that must have been added together to give me the original fraction that I started with.